Good morning, or good afternoon, sorry.
Good afternoon. You pulled me.
What's that?
You pulled me.
I did.
I do that all the time.
I don't know what that means. Morning, Kennedy.
Morning.
Morning, Jaco. Morning, Jackson. Morning.
It's
Haley.
actually afternoon.
Okay, it's all right. It's afternoon. I just
Good morning, Mr. Richards.
It's time. It's afternoon.
good afternoon.
Sorry, Jacob.
Cameron?
Good afternoon, Ed. Good afternoon, Cameron.
Hi.
Have you guys eaten lunch yet?
No.
Never.
Full class.
We can still
Your class is taking by lunchtime.
I'll just drink my water instead.
H2O. See?
Good afternoon, Mackenzie.
Good afternoon, Mr. Richards.
There you
I was in math.
How
Oh.
many times do you have math a day, Kenzie?
What?
How many times do you have math a day? Daily?
You have math 5 times a day?
Yes, I have math 5 times a day, Mr. Richards.
Yeah.
If I had math 5 times a day, I think I would drop out of school right now.
Hey, I'm
Like,
not really. No, I ain't doing this. Nope, I ain't doing this if that was happening to me. I'm actually not in bed. I just got my blanket because it's cold.
Sure, Cameron.
I'm not. So I'm not even in bed.
You
bed-
are not believing in right now.
He's here.
Hi, Dad.
I didn't leave my bed for like.
Richards.
Hello.
Hello.
oh, I thought you said hi, Dad, Shane. I was like, wait a second.
Oh, that would have been. I mean. Just kidding.
Phone charger.
Okay, so Isaac's late and Brooke is late. Who else is late?
Brooke's always late today. Like,
Well,
I was late to art. I thought that I had plenty of time to get onto art, and I was
every day we have art. I think it's at 2, and I go on there at 2, and I'm like, why is nobody on here? And then I'm like, oh wait.
2:30
lot.
now.
Art was so fun yesterday.
Yeah.
You guys didn't think so, but I thought it was so much fun.
What'd you do, Cameron?
We like swatched watercolor stuff, and it was
so
so fun. I mean, it was a long time.
I'm in class.
We were there for like an hour, but I mean,
Well, good. All right. We'll go ahead and get started. I don't know where the other ones are.
they're tardy.
Yeah, they're tardy.
They get a
Lab license.
lab license. I was like, what's it called? What's it called?
Are you still hitting those out?
Okay, go to Google Classroom. We're going to look at that 3-column worksheet that we worked on last time. I only had 3 of you actually turn that assignment in.
Which one? There's like 4 worksheets.
No, the 3-column worksheet on work, power, force, work, and power. Okay, so let's go to Google Classroom.
I got all of them besides when and where do they want. Yeah, that one.
Okay, thanks for sharing.
You're welcome.
I actually got all of them. I'm surprised by my old self.
Good for
Not
you.
that, like I wouldn't do it, but like because I do all my homework,
Okay, cool. Now you do?
every single bit of it.
Really?
I'm
No,
gonna go to
you
Harvard.
didn't.
I mean, I can't go to there now because Corona. But
Where do you go?
I said I can't go to Harvard
Share my
now.
screen so we can go over it as you're going over it or finishing it. Ed, you doing better at homework at home there, or is it the same old, same old?
What's homework?
Oh gosh. All
He's
right.
so quiet, like every day, and it's weird.
All right. Sharing.
Edward.
Mr. Richards.
Yes.
It's bad. So you guys are gonna probably cut out and stuff too. So
I wish I could understand what you just said, but I just got every other word.
You glitched really bad.
Okay, what did you say?
Me?
I don't know. Who just, wasn't it Shayna?
my end is very bad.
Oh, your internet's really bad?
Yeah.
Sorry. It sounded like this. My net very
Yeah.
bad. I could just talk like that and make you guys think that all your internets are bad.
I could do that in
Don't leave the Zoom.
Then I could ask to leave.
We
Miss
might work
and
on
I will leave, Mr. Richard.
I am.
third column.
I
Let's see.
have
Let's
to
first of all,
leave.
let's go down here to these calculations.
Oh yay.
That
That
didn't-
I couldn't figure out.
Jacob, be optimistic.
There you go.
See,
So, an object is moving at 2 meters per second squared. So 2 meters per second squared must be its acceleration. It has a mass of 3 kilograms. So what is the force causing this motion? So if it's force we want to figure out, let me stop share here. Hold on. There's,
sorry. I'm just done.
Wow.
Wow.
No, my grades went down in geography.
Oh,
Coming up.
Mine's a solid 100.
Wait,
Really?
it's gonna change in a minute.
let me see mine. It's probably
okay,
fake.
so we know force equals mass times acceleration. So, Cameron.
Oh my god, I have a 99.
All right, Cameron, muting you. Hey. If an object is moving at 2, has a mass of 3, what would be the force? Raise your hand. Haley's got it.
6.
6. 6 what?
6 meters per second.
Ooh, good guess.
Haha. Yeah, I don't know.
6. Shayna? Jones? Shayna? Jones?
N.
6N.
They're also known as newtons.
Correct. All right, second one, the formula, because I think that was all that we had there. Yes. If a 3 Newton force is used to move an object 6 meters, how much work is done? Remember, work is force times distance. So, force times distance. Cameron?
18 joules. That's it.
18
Haha.
joules is correct.
I think you're on the wrong one. Wait. No, you're not. My bad. Sorry, I'm a mistake.
We know.
Kenzie.
Kenzie?
All right,
I could sue you.
power. Definition. Who's got a good definition for power? Someone we haven't heard from yet. Speak up. Okay, Mackenzie. What's power?
Power is the Wyatt equal to 1 joule.
Okay, but what would be the definition of power?
That's what I put. I don't know. That's what I had.
Okay, we're going to say it's the amount of work used. Well, you can't see that, can you? There. The amount of work used or done on an object in a certain amount of time.
I think I totally got that wrong.
Really? Well, this is a good time to correct it then.
You know.
Can you unsubmit it and,
Yeah.
all right. Okay, what units do we use for power? How about Petunia?
Watts.
A watt.
Hope.
And when do we know power has been used? Volunteers? Okay, Jackson. When do we know power has been used?
When the temperature changes.
Okay, you just searched that, didn't you?
No, that's what I had it on here.
Really?
Yeah.
How about if we just stick with forces, though? So we would know power's been used when a force is used to move an object in a certain time of year. Whose music do we get the pleasure of enjoying?
Probably Cameron.
It's not me, I swear.
Oh, we'll just mute him again. All right. This is the same guy here, James Jewell.
Whoa.
And formula, power is work divided by time. And now for the problem. Jaco, how about you? If it takes 15 seconds to move a 12 Newton crate a distance of 4 meters, how much power is used? Now, this is a two-step problem. You just can't plug those 3 numbers into something, okay? You have to solve something first and then divide it. Cameron, you're still muted.
5.
Okay, so 12 times 4, you have to multiply those first. So 12 times 4 and then divide it by 15. So do we get 5? Jones, what's the answer?
3.2
Okay, 3.2 what?
watts.
What? What did you say?
W.
All right, 3.2 watts. Okay, there shouldn't be a reason that they're not completed now since we just completed them together. So hopefully when I relook at this worksheet, it's more than 3 of them turned in. Okay, let's go to the calculation worksheet. Some of you finished the whole thing. If you remember, all I wanted you to do was really finish half of it, but
What worksheet?
it's the calculation one.
Work and power worksheet.
I think so.
Work and power calculation worksheet number 1.
Yeah, work and power
Yeah.
calculation worksheet number
Bro, I
1.
don't even remember this. I definitely didn't do it.
I submitted it.
Is that a good thing?
No, because I probably failed
Ouch.
it.
Wait, can I? Yeah, if I do get one wrong, can I like unsubmit it and then?
Yeah, that's a great idea.
Will it count as late though?
How
It's not
about,
today.
yeah, but I would rather you have the like the correct answer.
Okay.
Can I do the first one, Mr. Richards?
Would you like to?
Yeah.
Okay.
Oh my
So
word.
you must exert a force of 4.5 newtons on a book, slide it across the table. You do 2.7 joules of work. How far have you moved the book? Remember, work is force times distance, right?
Yeah.
So it says we already
I'm
did
supposed to put that on.
2.7,
Oops.
and the force is 4.5. Whoop. Okay, so Mackenzie, what is it?
0.6 m.
What does the M stand for?
No, I know what it is. No, I don't. I don't remember. I remember. Yeah.
Well, the question is saying what? It's how far have you moved the book? So,
Mass. I don't know.
hey, in France, locked up in a safe, there is a stick about yay big. Some people come into the science room and want to borrow a yardstick, and I get angry at them because it's not a yard, Mackenzie.
Starts
It's,
with an M.
Meter stick.
yeah, so 0.6.
Meters.
Yeah. All right. Question number 2. A child pulls a sled up a snow-covered hill. The child does 405 joules of work. So we're going to use the same equation. Work equals force times distance. 405 joules. I equals the force times the distance is given as 15. What does the M stand for, Mackenzie?
Meters.
There you go.
Yeah, meters.
All right. Hey, what's the answer, Cameron? 405 divided by 15, Cameron.
You
Cameron?
muted me.
Cameron,
What?
what's the answer?
You muted me.
And you're not muted anymore.
Oh. I don't know.
All right, Jackson.
It's 27 newtons.
27 newtons.
Mm-hmm.
Got that, Cameron?
Yeah.
All right. Okay, again, number 3, how much work is done? So again, work is force times distance. Thirty 3,150 newtons is got to be the force exerted to move it 75.5 meters. So all you have to do is figure out the amount of work. Multiply them together. Ed, grace us with your answer.
What I got was 237,825.
237,805.
25.
825.
Yep.
Okay, and it's work, so the answer is the unit's going to be in.
Joules.
Okay, we agree with that answer?
Yeah.
Okay, number 4, a crate's being lifted into a truck. It's moved with that force. That amount of work is done. So now how far? So we're looking for distance. So force, look, work equals force times distance. Work is 3,650. Force is 2,470. Haley, why don't you grace us with an answer on that one?
Hold on.
Oh, come on.
There.
Make Mrs. Lewis answer it.
I got a decimal.
You
I
got
did.
Yeah.
it should be something larger than 1 because you rearrange that, you're going to get 3,650 divided by 2470. So maybe
Yeah. So I got 1.47.
Okay.
7.327.
okay, 1.
And I rounded it up.
Yeah, I did 1.4.
1.48.
I did 4.9. I mean 1.49. Sorry, wrong numbers.
It's 7.7, so it'd be 8.
Well,
So yeah, Mackenzie, change it.
calm
1.4
your soul, Mr. Richards.
1.48 what? Starts with an M, Mackenzie. What is it?
I already said it, meters.
Oh, you did? Okay, sorry. All right, number 5. That much work. There's the distance. Asking for force. So work equals force times distance. $16,700.
Divided.
So all you have to do there is take the 16,700 and divide it by 3.05. Jacob?
Yes, I'll answer it. 5,475 newtons.
5,435?
75.
75?
I got 85. Oops.
Maybe your calculator's broken.
Maybe it's the operator.
Probably right about that.
You're not okay to agree with me, Mr. Richards.
Oh, I thought someone else was pushing the buttons for you.
Yeah, my 3-year-old sister.
Okay, number 6, an elephant pushes with 2,000 newtons on a load of trees. If it then pushes these trees for 150 meters, so work equals force times distance. So 2,000 times 150.
3. No matter. I'm not even going to say my answer because it's probably wrong, and Mr. Richards is going to laugh at me.
Oh, Brooke has joined us. Okay, Ed, how about you?
I got 300,000 joules.
Oh, I was right.
300,000 joules. Brooke, we're going over the calculation worksheet.
Okay, I literally thought this at 1, so my bad.
Okay, number 7. I think it's got to be Petunia's turn. 190,000 watts. Engine can accelerate from rest to a top speed in 9 seconds. How much work did the engine do?
I said 21,111.1 joules.
Okay, so now we're using the power equals work over time. So work is 190,000 divided by 9. And what'd you get?
21,111.1 joules.
We're in agreement? Okay, number 8, another engine reaches the top speed from rest in 7.5 seconds. It's able to perform 250,000 joules of work. So same equation. Power equals work over time. So 250,000 divided by that time of 7.5. And Brooke, since you came in late, we'll pick on you. Got an
All
answer
right.
for us?
The net force?
No, the answer for that one, sorry.
Oh, okay. I had 33,333 watts.
We agree, you guys?
Yeah.
All right. Number 9, if a runner exerts 350 joules of work to make 125 watts of power, then how long did it take the runner to do the work? So same equation, power equals work over time. So work, 350. Whoops, I'll start with power, sorry. Power equals work divided by the time interval. So on that, you have to kind of, cross multiply. Solve for t. So 350 divided by 125. And who's got an answer? Don't all
I
yell.
do, but
Joe?
it's probably wrong.
Okay, well, tell us your wrong answer.
2.8 seconds?
That's what I had.
Yeah, me too.
Yeah, I
Okay.
have that.
All right.
Yay. We're done.
Yay. All right, go to Google Classroom, please.
Where are we going in Google Classroom?
Okay, on Google Classroom. Okay, there should be something called Playlist Little Newton.
Playlist.
Playlist Little Newt and the Force of Energy.
Yeah,
On there.
I guess it's listed twice. It's under educational games.
Sign up or log in.
Yes. Log in with Google, I believe.
Which one? The game?
Yeah, the Help Little Newton.
Wait.
Start playing it.
So what you're going to want to do is I want you to play that game and I want you to win that game until you find this message.
What message?
I can't see.
What are?
This
Am I
one.
supposed to sign in or log?
Log in with Google.
All right.
So you're,
about-
it's kind of fun. Plus it like teaches you about different forces and talks a little bit about friction. But you see what I want you to do?
Yeah.
All right. So get to the end and save Little Newton, please.
And do you just want us to email the
And
screenshot?
then just send me the screenshot. You'll probably like it even better than Rags to Riches.
Oh gosh.
It's kind of fun. It took me a
so
while,
much
but I
science teacher, if it took you a while, imagine.
I know. It killed like
I thought you were done for.
it didn't really tell me like what was going.
I thought you were done for.
Stop.
Sorry.
All right. So
When did that do?
This won't shut
I'm
up. I'm done with that.
So like if I was in the
also-
middle.
Hey, Cameron, stop talking. Right, the other thing assigned is that work and power pogo. Right. So before you guys leave, on that work and power pogo, I want to clean something up that some of you submitted. No. Let me open it up here. Be patient. Stop it. Is that Cameron again?
No, it's me. I don't know how to stop it.
There. We'll just mute you. Okay, on that pogo, my screen should be moving, but okay, there it goes. Oh my gosh. My time's gonna run out by the time I'm able to scroll. Okay, when you do yours, do you see my screen? Oh my gosh.
Ow.
When you have to add arrows here, check your arrows, right? The weight the mass of it, the 50 kilograms, that's going to be an arrow that you have to draw pointing down. Right? If you scroll up and look at the other one, right? The weight goes down, the push of the ground goes up. You pull one way, friction pulls the other way. Right? All the arrows, I think, point in different directions. So I saw a couple that were submitted that the two arrows on the sides both pointed the same direction. The two arrows on the top and the bottom both pointed the same direction. So, but they all should be opposites. So right arrow, left arrow, up arrow, down arrow, okay? So if you have to make those corrections, then submit it and correct it. The other thing that you might see on Google Classroom is a link to a game, but I mean, you can get there, try to log in and figure it out, but don't stress about it. We won't worry about that Explore Learning thing until next week. There's a gizmo about work and power, I think. But just help little Newton. When you help little Newton, then make sure you get him to home and send me a screenshot, okay?
I have a question.
Yes.
All right, so how do I can't find the weight or the ground, but I got like the other ones.
On that pogo?
Yeah.
Okay, well, it's a 50 kilogram mass, right?
Yeah.
Okay, so an acceleration of gravity is like 10. So just take 50 times 10, which would be 500.
Mhm.
Right, and that would be the weight of it.
And the same thing for the ground, or what?
Yeah, because it's not sinking or rising. So the ground's pushing up with 500 and the weight's pushing down with 500.
All right.
Okay. Okay, have fun saving little Newton.
Yay.
All we have to do.
We'll
All
see
right.
you guys next week.
I'm like over excited.
I know. Bye, guys.
Bye. Have a great afternoon.
You too.
I will not have fun.
Sure you will.